Welcome to today's video, where we're going to delve into a common problem faced by developers when working with functions in TypeScript. If you've ever wondered why functions are contravariant with their parameters, you're in the right place. Let's break it down step by step and get to the bottom of this conundrum. Let's start exploring the solution to our problem with a concrete example involving two classes, animal and dog. In the example provided, the dog class extends the animal class, inheriting its methods. This inheritance relationship sets the stage for our exploration into contravariance with functions in TypeScript. Pay close attention to how the classes are structured, as it forms the basis of our understanding. Continuing with our exploration, let's consider the scenario where we allow assignment between a dog and an animal. We observe that substituting a dog for an animal is permissible, as the dog class encompasses all the methods of the animal class. TypeScript recognizes and permits this assignment, ensuring type safety and preventing runtime errors. Moving on, let's examine the opposite scenario where we attempt to substitute an animal for a dog. This situation raises a red flag, as the animal class lacks the specific methods present in the dog class. TypeScript intervenes here to prevent potential runtime failures by disallowing this type of assignment. Now, let's shift our focus to function types in TypeScript. Just like with class assignments, language designers face a choice regarding contravariance with function parameters. By analyzing how functions behave with parameters, we gain deeper insight into why contravariance is essential in maintaining type safety and preventing runtime errors. Digging deeper into our example, we see how TypeScript handles function assignments between useAnimal and useDog. TypeScript's enforcement of contravariance ensures that passing a dog to a function expecting an animal is safe, as the dog encompasses all the behaviors of the animal. This type of assignment is permitted and aligns with the principles of contravariance. Continuing our exploration, we encounter a scenario where attempting to pass an animal to a function expecting a dog would lead to runtime failures due to missing methods. TypeScript steps in to prevent such scenarios, highlighting the importance of contravariance in maintaining type safety and preventing unexpected errors. To wrap it all up, we've dived deep into the world of contravariance with functions in TypeScript, unraveling the intricacies of type safety and runtime error prevention. By understanding how functions behave with parameters and leveraging contravariance, developers can write more robust and reliable code. Thanks for watching, and remember to subscribe, like, and comment below with your thoughts. Until next time, happy coding!